Well, thank you everyone for taking some time out of your day here. I know we're all very busy and we really do appreciate it. So welcome to our webinar on dust collection best practices. So we've got our sales team here today and I'll just do a quick intro. My name is Matt Coughlin. For those of you who haven't met me, I see there's a few familiar names on the list, so that's great. We have Dominic Del Santo, our sales director, who's been doing dust collection for how many years, Dominic?
Since I was old enough to jump in the hopper and pick up the screwdrivers that fell down. So
Yep,
something like 20 years.
family business for Dominic. We've got Scott, who our sales associate, who many of you have interacted with, who's been with us for several years as well. You want to say hi there, Scott?
Hi, good morning. Good afternoon, everyone. Nice to meet you. I see some familiar names there too, so thanks for joining us.
Yeah, and we've got Andy, who many of you, probably most, will recognize by name from all of his communications out there. So Andy, our sales and marketing director here, who helped pull this whole presentation together.
It's very nice to have you with us today. Thanks for coming.
Yep, and just kind of an FYI, everyone's going to be muted during the presentation. We do have a Q&A session at the end where we're going to take the questions that have been submitted to us and we'll provide answers to those. But so if you're trying to unmute or raise your hand or something, you won't be able to during the course of the presentation, just for your awareness there. So I'll kick things off here just by kind of going through the agenda. Andy, if you want to click ahead there. So we're going to have a few different sessions, if you will, to kind of address the biggest topics that come up with customers. And I hope that regardless of your function or your company, your industry, you'll be able to get something useful out of this webinar. So we're going to go through kind of why is this important to you? I assume since you're on the webinar, your business does some kind of dust collection or handles dust in some manner. So it probably does affect you. We're going to talk about filtration principles, which is one of those really important things that we find that really impacts how your business is going to operate in terms of dust collection. A lot of people get things wrong when it comes to filtration. So Scott's going to walk us through some of that. We're going to talk about the three most common things that come up as issues with your dust collectors. I imagine most of you will be familiar with at least one of these things that we're going to go through, some basic troubleshooting tips, if you will. And then we're going to talk a little bit about designing of an entire system. So if there are any engineers or capital project managers on the line, they're looking at investing in a new dust collection system. There's some really important principles that Dominic's going to walk us through. And then at the end, we're going to talk about our latest training offering, which is something many customers have been asking for and about. And we'll talk about a couple of new options that we have for training of customers out there. And then at the very end, we'll do the Q&A. So go ahead to the next slide there, Andy. So who is this for? We have an interesting position in that we have customers in virtually every industry out there, from aerospace manufacturing to mining to food production, pharmaceuticals, you name it. If dust is produced, then they're potentially a customer, and we've got our people in there helping them with dust collection. So across those industries, there's all different kinds of company structures. So depending on how your company's structured, dust collection may fall into a number of different categories. Most often, first point of contact for us is maintenance managers and maintenance technicians. People call us the guys on the ground, boots on the ground that have dust problems. Usually the first one there is the maintenance guy. So, seems like every site we go to, there's one guy who's been there forever. Call him Old Bill, if you will. Old Bill was there when the whole system got put in, and he knows how to fix it, knows how it works, knows what needs to be done. And then there's a lot of typically younger, newer engineers or maintenance people who are trying to get up to speed and rely a lot on Old Bill's tribal knowledge. So we try to design our training material so that it's useful for old Bill, sure, but it's also useful for the newer generation of employees, maintenance people, engineers who are trying to address problems and spec out new equipment, procurement people who are having to cut POs and figure out why they're spending so much on filters, things like that. Of course, EH&S people are always involved. We've got permitting issues, we've got compliance and legal things. Safety is paramount for the guy on the floor, the guy and gal on the floor that are having to deal with this dust. So we hope that our training material will have something for just about everyone. When we do the in-person class, the most successful classes we do is when it's maintenance, operations, engineering, EH&S, management. There's a whole cross section of people because it really does require a cross section of capabilities to make sure that your dust collection systems are operating properly, that they're put in right, and that you have the right equipment. So with that, I will turn it over to Dominic to talk a little bit more about why this is important to you.
Thanks, Matt. So we want to highlight here a couple of reasons why you should care about our dust collectors. Why it's important for your business, why it's important for you. And let's start by talking about our first slide here. Reasons we have the dust collectors is because they provide a safe working environment, clean working environment for everybody that works at the facility. And it's easy to overlook that sometimes if we're in the office, but the reality is everybody suffers if the environment is dirty in the plant. But more than just providing something that's comfortable, it's really a matter of safety in many instances. Obviously, there's toxic chemicals, things that are hazardous that we work with sometimes that have to be maintained clean. But many times even dust that's not toxic is something that's a hazard when it's found in large amounts in a work environment. And that's why there's specific OSHA regulations we have to comply with many times. And a very large, very important aspect of that also is dust that are combustible. So these could be things like food, these things could be metals, things that we don't think of normally as hazardous, but actually when present in a dusty environment, when dust is built up, they become very big safety hazards and present a real life hazard to your workers and to your equipment and to your facility. So making sure the system works well, maintains that environment that's safe for everybody. Because at the end of the day, we want everyone to enjoy working for us, be able to go home at the end of the day, while also being productive. Now, the second reason why we should care about them is that it's necessary to have a good dust collection system that operates well in order to achieve compliance with environmental regulations. So there's definitely a lot of pushback in some areas about environmental regulations that a plant has to meet. And it's a little bit of a patchwork, so it creates quite a lot of different views on the subject. Some people feel that theirs is very simple, they don't do anything that's polluting, so they don't need to worry about it so much. Or they've always had it easy from the regulators, and that's going to stay that way forever because where we live, it's this way. Maybe in other places, but here it's going to stay this way. The reality is the regulations don't get looser as time goes on. They get tougher and tougher, more stringent, and less we see things like grandfather clauses that let you continue operating how you always have. And new regulations come into effect after many years of analysis and implementation. And sometimes it's just a matter of you've had an old inspector that did things a certain way for many years. All it takes is that new inspector to come in or someone else to rotate in. And now all of a sudden you feel like you're facing all kinds of different regulations you never had to comply with before. Well, what's the story? The story is that it's always been your responsibility. Perhaps it just wasn't enforced. So we should get rid of the idea that we're always going to be able to sneak under the radar if we do this or that, or we do it this way. Sooner or later, we all have to comply with the newer regulations. And key to doing that is having the dust collection system work well. And this also applies with things like older types of collectors, older systems. Just because they used to meet compliance, you used to get a pass from the inspector, not going to be the case anymore. And it's important because when we have violations of the air permits, right, we have things like fines, we get sanctions, or we might even reduce our output, or we can have shutdowns, and of course, negative publicity that's generated as well. Now, our other reason here that we can mention, our third reason, is that having a well-designed and operated system, it protects the quality of the products you manufacture and also the equipment in your facility, and it's just conducive to higher productivity. So what do we mean by that? Well, many process applications produce materials or final goods where the quality is directly impacted by how good the dust collection system works. Think about things like pharmaceuticals, food products, precious metals. We worked many years ago at the platinum metals group mine, and that plant was so clean because by the time the dust leaves, it comes in the plant in a large dumpster, and it's worth several $100,000. By the time it leaves, that same dumpster has been reduced down to a paint bucket that's worth tens of millions of dollars. So every single speck of dust in that plant was reused because it was valuable. So we can think of an extreme case like that. But it goes for other things too that are somewhere in the middle there. If the dust collector is not working well, it affects quality, it affects output, things like that. And the same goes with manufactured goods. We work at several large guitar factories, for example, and if the dust collection system is not working well in one part of the plant, they actually had a big problem where airborne dust was lofting over and affecting the painting and finishing areas of the plant, completely on the other side of the plant. And it was causing them more delays, lowering the quality of the finishes. So having the dust collection system work well for them directly impacted how long it took them to manufacture each good that went out of the plant. And then kind of indirect costs we can think of. A dirty plant means that every piece of equipment in there is now subject to be damaged by it. Every conveyor, every mechanical device, every motor, every light switch, everything you could possibly think of in there is now subject to fugitive dust, dust piling on top of it. All of those things wear down that equipment that in the long run costs you and your plant more money. And then finally, it's just common sense that if our plant is dirty, it's hard to move around, there's large dust piles everywhere, it just makes it difficult to get things done. Same reason your mom or dad taught you to clean your room when you were a kid. When things are clean, everything works better. And our plants are no different. If our plants are dirty, it's just harder to make things and get stuff done. So these three reasons we've just talked about, having compliance with environmental purposes, making sure that our workspaces are safe, as well as just keeping a clean environment for productivity reasons, they're all reasons you should care about your dust collection system. And we just want to clarify something. We know it's the least fun thing to talk about or work on. I mean, it's our business and we don't even like getting in them either. But don't let your dislike of the dirty piece of equipment let you overlook their importance. Because often when they're neglected, they become the thing you spend most of your time working on. And then instead of being people that make products that do this, do that, you become people who are professional baghouse problem solvers, problem attenders. And that's not the purpose of our businesses. Our business is to do something that makes profit, that we enjoy, that serves a greater purpose. It's not there to work on baghouses. So if we pay attention to them, we can avoid spending all of our time being baghouse people and get back to doing what's important. So now we'll go on to our next part, which I believe is Scott. And he's going to talk to us about some concepts that we have with dust collection that we like to make a point to clarify with our customers because they really are holding you back if you don't understand these four concepts well. So Scott, let's hear what you have.
Very good. That's right. Good afternoon again, everyone. We're going to go over in this part, as you can see on your screen there, some different ideas or maybe some confusion that's out there about filtering a dust collection system, your baghouse, for example. We're going to be able to, in this part, define the difference between a baghouse dust collector and a dust collection system, how that all fits together. How can we look at the big picture of things? At your plants, you probably have a couple different types of dust collectors as well. Are they all created equal? What are the different types of dust collectors that we have? How can we choose the correct one for our application? How is it that the filters actually catch the dust? How does that work exactly? And then talking about our filters for our baghouses or our cartridge collectors, what happens when they fail early? how long can we use our baghouse filters for? How long should they last? We'll be able to talk about that a little bit toward the end of this part. So we want to make sure that, again, we understand these concepts to be able to have our baghouses working well instead of not working at all. And when we do have problems, being able to identify them to prevent them in the future as well. So if we go to the next slide there, Andy, if we look at baghouse dust collection as a system, as a whole, there we go. One concept that we want to make sure that we understand pretty clearly is, what is the purpose of a collector? Why do we have a dust collector in our plants? Real briefly, we have three main reasons there. One is for pollution control. We're creating some sort of dust that might be hazardous or toxic to the environment. It might be a dust that isn't with those different types of things. Sorry about that. But we want to make sure that it is being collected. We might be sanding, we might be cutting, we might be polishing something. We want to make sure that we don't have any type of issue with pollution getting onto the neighbors' houses or people calling pollution control, things like that. Health and safety, as we outlined in the very beginning part of this webinar, worker safety is very important. We want to make sure that everybody is able to work in a clean environment. Having 6 inches of dust on our dust collectors probably isn't the best for that machine, that piece of equipment. It affects overall product quality. It affects overall profitability by not having things clean. Maybe we have operators that, instead of operating different parts of the plant, they're glorified cleaners. They have to pick up the dust and clean the plant in that way. We want to make sure that we can avoid some of those issues. If we have combustible dust as well, all of that dust sitting there in a way is kind of waiting for a bad accident to happen, something that could explode or could catch fire very easily. And then thirdly, one of the more common ways is we have some sort of process. We're moving some sort of bulk material from one part of the plant to another. It could be as simple as a trucker blowing into a silo where we have to have some sort of bin vent or even a filter receiver at the top of those silos. We have some sort of process that's creating some sort of dust that does need to be collected. Maybe at your guys' plants, you can think of like a couple different reasons as to why we have collectors. Maybe it even fulfills 2 or even 3 of those different reasons there. So again, we don't want to think of just the baghouse as doing all the work. That's the only part of a dust collection system. We want to look at the bigger picture. What are we trying to accomplish? And how are we trying to avoid having any additional dust or nuisance dust? So if we go to the next slide, are all dust collectors created equal? Can we have a baghouse where we'd have a different type of an application? What are the differences? Well, no. We have different baghouses or different collectors created for specific reasons. For example, we have our mechanical dust collectors that would be something like a cyclone or a knockout box. It's essentially a dust collector, but just without the filters. Can we use a cyclone in replacement of a baghouse? Well, not really. So we want to make sure that we understand that it's a type of dust collector, but it doesn't replace another type of collector, such as the pulse jet baghouse, for example. Next, we have a specialty collector that could be like our wet collector, a scrubber, precipitator, maybe something that's dealing with a corrosive material, again, collecting the dust, but acts differently than a cyclone or a traditional baghouse. And finally, we have our filter dust collectors, which probably everybody can think of would be your baghouses, would be your cartridge collectors, filter receiver as well, maybe something that has pleated filters. Again, using some sort of filter to be able to clean the dust or separate the dust from the air. So this afternoon, we're going to talk a little bit more about the fabric filter dust collectors. So if we go to the next slide there, under the umbrella of baghouses or dust collectors, we have a couple different types that we can choose from. Again, we want to make sure we understand the concept of being able to choose the, correctly choose the collector that we need for our system. We have the first one there, our shaker dust collector. It's a little bit of an older technology, more of our legacy units that we don't see as much today. They're generally a bit less efficient than some of our reverse air baghouses or our pulse jet baghouses. Essentially, you have to shake the baghouse filters with some sort of shaking mechanism, cut off the airflow first. We can't keep operating, we can't keep our process going. So that's why they're a little bit inefficient and we don't see them as much today. Secondly, we have our reverse air bakehouse, which is generally a very large bakehouse for maybe 100,000, 125,000 CFM as a base or larger. Generally, we see reverse air bakehouses at power plants. Essentially, the airflow again is stopped, blown back into the filters to be able to clean them. We don't see these quite as often because, again, we have to have different compartments that either shut down or turned off to be able to clean our bakehouse filters. So we have very specific applications for either a shaker or reverse air. So the much more common bakehouse cartridge collector, dust collector that we see today would be our pulse jets. As you guys probably know, you have a number of them at your plants. These are our collectors that are able to clean online, where we have a burst of air, a pulse of air that's able to clean the bags as the air continues to move through the system. So we can use these for a wide number of industries. We can collect a large amount of dust with these types of collectors. So really, these are kind of our leaders in terms of dust collection. So we'll talk about this a little bit more, a little bit later on in the section when we talk about designing a system. These are some of the different factors that we take into consideration when choosing a specific dust collection system. We want to look at the type of dust, the size of the dust, how much airflow. Sorry, Andy, if we go to the next screen there, factors to consider. Okay, we did take that one out. Okay, very good. That's all right. Like I said, we'll talk about that a little bit later, how we can choose the correct collector for our system in that. So we'll talk about that a little bit later. Sorry about that, guys. We had a last minute change there. All right, so the last concept that we're going to talk about then is our filtering. How is it that the filters actually capture the dust? And how is it that that works within our dust collection system? A lot of times people might call us and ask, how long are my filters supposed to last? Or are dirty filters a bad sign? How often do I need to change them out? Well, let's first understand how our filtering works within our collectors. And we'll be able to talk a little bit more about that in just a few minutes about how long our filters should last. So when we talk about air filtration, we have two primary ways of being able to filter dust from some sort of system. The first one is called depth filtration, as you can see on your screen there. Depth filtration would be like your HEPA filters or your panel filters, for example. They're very efficient at being able to capture even the smallest, tiniest piece of dust. The unfortunate part is that, as you know, if you've worked with HEPAs or panel filters, once they fill with dust, we can't clean them. We can't reuse them. We have to simply change them, toss them. In a dust collection application, these don't work for a bakehouse. We have too much dust. We have too much going on to be able to have to keep buying cartridges, once a month, things like that. So what we'll talk about next, in the next slide there, is surface filtration. Surface filtration works a bit different than depth filtration, as you can see on your screens there, where essentially the dust is collected on the outside of our filters. We can think of it maybe like as a fish net. If any of you are fishers out there, we lower the net into the lake or into the ocean. The net is what picks up the fish or anything else that we want to catch, right? These types of filters are stuck to the filter media. These are the ones types of filters that will still allow the air to pass through as well. As the dust gets stuck to the outside of our filters, we can pulse the bakehouse to clean the filters. At the same time, we can clean online. So that allows us to be able to clean certain rows of the bakehouse while still allowing the air to continue through the system. So they're very efficient in that way as well. Versus depth filtration with our HEPAs or panel filters within our bagehouses are able to be cleaned and reused repeatedly. We can get, thousands or tens of thousands of cycles out of our bakehouse filters, and they're able to handle a very large amount of dust as well, in contrast to our other types of filters. So really, this type of filtration is very efficient, and that's kind of our gold standard when we talk about bakehouse dust collection. The other great thing about these types of filters and using surface filtration is that we have something that will eventually stick to the filter that's called our dust cake. Eventually, the dust that does get stuck to the filter will develop, And that's why we don't always consider to have a dirty bakehouse as something bad. Our dust particles that are stuck to that surface of the filter are really assisting the filter in doing the filtering. So it's really a good thing, actually, to be able to have a small layer of dust on them. Our dust collector filters are designed in that way. We obviously don't want to over clean our bag by knocking off all the dust cake from our bags, and we don't want to under clean as well, that our airflow would start to be affected. So we want to find a nice even middle ground there. But again, those are the two main concepts between depth filtration and surface filtration, and why really only surface filtration works within our dust collector and dust collection systems. If we go to the next slide here, if we understand then the concept between depth filtration and surface filtration, how often do we need to change out our filters, or how long should my filters last? Sometimes in some plants that we go to that we visit, the filters have been changed on a regular basis, every one of them within a collector. And in some places, maybe they've never been changed, but whenever a hole is developed when the filter bag, they change it. But perhaps they always spot change every 744 bags within a bag house. What's the idea behind that? Well, we want to be able to identify a little bit more easily when we need to change out our bags. What is the optimal operating condition for our bag houses? So we're going to talk here first about early filter failure versus end of life filter failure. The first concept that we want to understand then is early filter failure, and that's when something damages our filter or causes it to fail. Something that is outside the normal operating guidelines. We can see the picture there of the flat tire. Let's say it hit a nail in the morning. You weren't expecting to drive over a nail with your car. You weren't expecting, to have to go to the mechanic, get it fixed. But whatever you hit, that nail caused your tire to fail. You can't keep driving. You have to stop. You have to fix it. The same thing with our filters on our bag house. Something happened within the bag house where we had to stop, change out that filter, and then we can continue on our way. Generally, we have three different things that can happen: thermal durability, abrasion, or a chemical attack. If we talk about thermal durability, that's one of the more common one that we see today. Temperature. That's basically where the maximum operating temperature of our filters was exceeded. Maybe something got too hot and passed through the bag house. Generally, our filters can only go about 15 or 20 minutes with with that excess high temperature rating. Maybe we sucked up a spark or some sort of ember that physically caught the bags on fire, or maybe they just damaged them. So it'd be the first reason as to why our bags would fail, some sort of thermal abrasion, or something that happened via temperature. The second one would be abrasion. Abrasion comes in many different forms. That's where we have different dust particles coming in, and maybe because of a design error with the bag house or the wrong type of bag in our bag house, they weren't able to stand that type of dust. Generally, this abrasion will wear holes toward the bottom of our filters. Also, too, abrasion could come in the form of reusing our old cages. If our old cages are bent or rusty, when our bag house is pulsing, it could be that a bent cage actually rubs against a nice new filter, causes a hole in the bag. Whatever it is, bag abrasion is something we want to avoid because it causes our filters to fail early. And then lastly, we have a chemical attack. The most common one that we see is something that's called hydrolysis, where moisture, water is in our airstream, what's going through the bag house, and causes it to react with other chemicals or compounds that when it goes to the filters, it either attacks them or causes them to fail early. So what concept do we want to understand? We want to avoid these different types of early filter failures to be able to get the most out of our bag house filters. So the next concept we want to understand then would be our next slide there: early filter failure versus end of life failure. End of life filter failure is basically being able to use our filters within a normal use until they have worn out. Again, if we go back to the tire illustration, an early bag failure would be like hitting our nail in the driveway. You got to change the tire immediately. You weren't expecting it. something came up. End of life failure is a lot different when we have driven our car 55,000 miles, our tread is now gone, but we were able to get a long time out of our tires. Well, the same thing with our filter bags. Eventually, our bags will wear out. We talked a little bit about the dust cape. We'll talk a little bit more about that later. Sometimes when we have bags that have been in our system for such a long time, little particles of dust actually work their way into the depth of the filter media. And as many times as we want to pulse, try to get that dust off, it's embedded into the fabric. So we really can't clean it any more than what's physically possible. Also, cleaning our baghouse filters over time does weaken them as well. They're made of fibers. That can be something that will cause them eventually to get to the end of their natural life as well. So the amount of time it takes to be able to reach end-of-life failure varies significantly. It varies just as with a car. It depends on how we drive, where we drive, the types of roads that we drive on, the types of tires that we have. A lot of factors are thrown in there, right? With our baghouse filters, it's the same way. Depends on the way the collector is operated, the types of filters that are used, and things like that. But why do we want to help people understand these two concepts? Well, people sometimes obviously get things wrong and they end up changing their filters only on a one-off basis, but all the time. So we want to make sure that we understand what our filters look like by the time they get to the end of their lifespan and be able to tell the difference between those that have been recently changed out. We also want to be able to help the filters get to the end of their life so we can change them all out, not just on a one-off basis. If we need to do that, that's fine, obviously. But the idea, the concept is that we don't want to keep running over nails in our driveway before we go to work every morning. We want to be able to identify that if we have early bag failure, there's some sort of problem, and we want to be able to correct that. So those are some different concepts that we touched on real briefly about our filters, what is a dust collector system as well, how that differs from only the baghouse. So hopefully that clears up a couple concepts that people have as well. All right, so this next part, we're going to go to Matt. We're going to pivot, and he's going to talk to us about troubleshooting the top 3 most common problems.
All right, very good. Thank you, Scott. So oftentimes the first call we get from a customer or a potential customer is something to do with these top 3 problems. If you have a dust collector at your site, most likely, unless everything is working perfectly, you've dealt with one of these 3 problems. So go ahead and move to the next one there, Andy, and we'll go through them one by one. And I hope, like as I mentioned earlier, maintenance people are usually our first point of contact that have to deal with this. So maintenance guys on the line, hopefully we can be some help here. So the first one is no vacuum or no suction, right? We design these big systems with fans and bag houses sized based on the number of pickups or drops you have on your system. You started it up on day 1, everything is sucking very well. There's dust being evacuated from your weld booth or your process, and everything is all good. What happens then a couple years later when that suction slowly decreases over time? And by the time we get a call, usually there's no suction over here. We've got issues over there. So there's a few things that we will go look at to diagnose that issue. So number 1 is the filters. It's a filter system, right? So just like Scott said, you have a filtration system with surface filtration where dust builds up on the filters. And as that dust builds up, the static pressure or the resistance to airflow across that whole system increases. So your fan might be pulling 10,000 CFM when you have 8 inches of static pressure in your system, but then now your filters are getting all clogged up with dust. So now you're at 12 inches of static pressure. So what happens if you go back to a fan curve, you'll see that the CFM essentially decreases in correlation with that. So first thing we always look at is the filters. And how do we do that? We go look at the differential pressure gauge in the bag house. So every collector should have a DP gauge or a magnehelic gauge or a differential pressure gauge, all the same thing, right? It'll just tell you what that static or differential pressure is across your filter. So brand new set of filters, maybe at 1 or below 1 inch water is the unit most often used. As the filters get packed with dust that will creep up to 2, 3, 4, 5 inches. And at some point, your filter cleaning system will kick on, blast it with compressed air or shake it, depending on your system. Whatever it is, it should knock the dust off. Static pressure goes down. And it should basically go back to operating the way you want. Over time, maybe you have reached that end of life failure where your filters are now blinded, your filter cleaning system isn't working like you want it to, and so the result is a static pressure that's higher than your design point and a minimized suction at your where you need it. So number one, we'll check the DP gauge. How are your filters doing? If necessary, we can do a visual inspection of the filters. Well, they're totally packed with dust. There's your problem. New filters, problem solved, right? That's the best case, right? Easiest thing to figure out. Number two is leaks. So you have duct work connecting your bag house, your fan to all of your pickup points. Sometimes that can be very extensive. You've got long duct runs. You have union fittings and elbows and hoods, which are all connected together. Over time, things can happen to that ductwork. You get cracks and joints come apart. You have abrasive dust that wears holes and elbows. You have interface points with flanges and other things that, for whatever reason, over time will develop cracks and gaps and leaks. And so what does that do? That takes all of the fan or the airflow that your fan is pulling, and it's wasting it. It's pulling it through those little cracks and leaks instead of through your nicely designed hood where you want it to be, right? So instead of 200 feet per minute through your hood, now you have lost, an eighth of your airflow over here. So you have less than ideal velocity, your pickup points, all kinds of problems, right? So that's number two, fairly common. Usually that's not the sole problem, unless you are talking about removing entire branches and leaving branches open to atmosphere, which we do sometimes see, so you want to minimize those leaks in your system. Go walk your ductwork, figure out where you may have air leaking, and fix it. Number two is the fan itself. So when we design a system, we design the ductwork first and figure out what the static pressure requirement, the velocity requirements, and the airflow requirements are for your system. We'll make the bag house sized appropriately, and then we'll choose a fan appropriately as well. So if you look at how fans are selected, usually it's by an airflow and a static pressure. So that's great when everything is just as designed, right? But what happens over time? Something we see almost everywhere we go. That system changes over time. Someone has decided at some point to add a machine, or we're going to close this branch here. We're going to move it over there. All those little changes that seem fairly innocuous, they add up and they change the static pressure of your ductwork, and they, will add a branch here. Now your airflow requirements have changed. That airflow is basically, the fan can only produce so much. So if you're adding branches, what are you doing? You're distributing it now between more pickups. And if you're changing the ductwork, your static pressure is changing. All that is changing the dynamics of your system. So your fan may not be up to the challenge now. It may also just be worn out. You may have a fan wheel that's been abraded with abrasive dust or something, and it's not pulling what it's supposed to do. So we'll look at the fan itself just from a basic maintenance and PM perspective and say, how does the fan wheel look? What's the fan RPM? We can stick a probe just upstream and figure out what the actual airflow and the vacuum pressure of that fan is, and make sure that it matches up to what it should be for your system. And then finally, some systems will have dampers, slide gates, and other manual methods of airflow control, which can greatly modify the balance of your system. So the fan itself might have a damper on the inlet or the outlet. You might have these located on trunk lines at various points in your system. And then a lot of the ductwork branches will have their own little dampers or slide gates, which people tend to open and close as needed. Your people, on the floor may shut off a branch or open a branch here when they need it. And all of that is changing the balance of your system, and it may be affecting your suction over here in another area without, realizing. So we'll go look at that and make sure everything that's should be open is open, and your dampers have some sort of methodology for how they're controlling your airflow. So vacuum problems come down to basically dust collection system basics, the filters, so the static pressure, leaks through the ductwork, your fan, what's the condition of your fan and how is it sized to perform, and then the dampers on the system. So those 4 things, if you're not getting suction, that should be your checklist to go look at. All right, next slide, Andy. Okay, the number 2 thing we hear is issues with cleaning. My baghouse is not cleaning. So most of the equipment that you'll have on your site are pulse jet baghouses. I know some people are working a big steel mill. You may have a reverse air type baghouse. Some people will have a shaker system. I won't get into the details of every system, but the most common thing is a pulse jet baghouse. So it's actually a very simple system. You have a timer. You have some solenoids, where basically just a little electrical valve that opens and closes. And you have a pulse valve, which takes compressed air and releases it through a blowpipe into your baghouse, 1 row at a time to clean your filter bags. So usually, if your cleaning system isn't functioning, one of those 3 or 4 components is the problem. So what I'll do is I'll go out and I'll stand there by the baghouse and I will listen. Now, if you have your timer set up on just a continuous mode, you know that at every 20 seconds it should fire. If it's not firing, well, then you can pretty safely say that either your timer board isn't working. Usually you can go look at it and see it'll have little visual indicators when each output fires. So check that. An electrical connection between your timer and your solenoid. So if you hear a click, or if you see the timer board fire, but you don't hear a click, you've got a solenoid that needs to be replaced. If you hear the solenoid click, but you don't hear a pulse of air, then most likely it's a pulse valve issue, or maybe it's your compressed air. Make sure it's turned on, obviously. Now, sometimes you have the whole system set up on clean on demand mode, which we recommend is the most efficient way. Basically, it means your system measures the differential pressure and it doesn't turn on until it reaches a set point, like 4 inches or whatever. So you might have to manipulate your DP tubes to get it to fire, but when you do that, it should activate the system. If it doesn't, again, it's one of those 3 issues. It's the timer board, it's your electrical connections or the solenoids, or it's the pulse valves themselves. Most oftentimes, if the system's firing, you hear it going, it's doing something, but your DP isn't really going down, or the bags are just not being cleaned the way you want. Most often, diaphragm, within the pulse valves, the diaphragms need to be changed. So when I hear it firing, you get to know the sound that it should have. It should have like a nice, firm, compressed air blast sound. If it sounds like a squeak or a whistle or a gasp, it's an indicator that your diaphragms are worn out, because they're just a little, rubber diaphragm in there. They flex and they wear out. Usually we recommend once a year, maybe clean those out, replace those as part of your regular PM schedule. That way you don't have to go do this exercise of listening to them. It's just getting done. The other thing occasionally we'll see is open up the baghouse. We'll look inside and the blow pipes have been knocked out of place. They've got some kind of a bulkhead fitting that usually holds them in place, or some kind of fastener, various different types, and they do occasionally get knocked out of place. So that's something worth looking at too. And then finally, check the bags themselves. If everything is working, the pulse valves are firing, it sounds good, everything should be working, but your DP is still high, the bags are still dirty. Check those bags and see if you have moisture getting to them, because that can really impact the performance of the filters, first of all, and then your cleaning system as well. It's not going to be able to clean mud off the bags if you get significant condensation. So that's something that we will occasionally see. So, okay, the couple items, you got your timer board, your pulse valves, your solenoids, the electrical connections, and your compressed air. So make a little checklist, go out there and check each one of those. One of those is your problem. If it's not, you have wet bags, then you should address that. But really, these systems are fairly simple once you understand the fundamentals, and that's where typically we'll find the problem. Next slide, please. All right. The final most common question is, why aren't my filters lasting? Or how long should they last? We always get the question, how often should I change the filters? How long do they last? As Andy said, or I'm sorry, as Scott said, of course, it depends how you run them. If you're running 24/7, a highly demanding application, abrasive dust, all those things, they won't last as long. If they're sporadically used, light dust loading, they'll last a lot longer. But, general rule of thumb, I like to say is like about a year. And it really depends on you, but people like to have a number to go by. So once a year is kind of a middle of the road estimate for how often you should change your filters. So what will cause them to fail early, or that end of life failure to not be as long as it should? Your cleaning system settings are important. So you want to set your cleaning system timer so that it's cleaning them enough to remove the dust cake and keep your differential pressure low, but it's not just cleaning them all the time just because essentially you're sending a shock wave of compressed air. It's flexing the bag, and over time you get like a fatigue failure, and the bags will wear out. We always recommend using clean on demand again, so you're not hitting them with compressed air until they really need it, right? You wait till your differential pressure gets to a set point, it runs a cycle, and then once you get below the low point, then it will turn off. That will help extend your bag's life. Washing of bags. We run into this from time to time. There are people out there who offer the service of laundering filter bags. Sounds like a good deal to save money on bags. Problem is, specifically with felted filter media, which is most commonly used for filter bags, introducing water to the filter fabric will basically degrade it and break it down. Just like if you've ever had a felt hat or those old-fashioned kind of felt hats, if you throw it in the laundry, it will not do well. It'll basically fall apart. Same thing happens with felted filter fabrics, like felted polyester and things like that. If you're in a pinch, you got to do what you got to do, right? Sometimes if you don't have an extra set of filters, which we of course recommend you do, and your system's down, some people will go and launder them and just to get their system up and running. I get it, but you should not expect those filters to last too long. That should be a stopgap and not something you do as a regular process. And then finally, filter media is extremely important. You have to have the right filter media for your bags. If you have a high temp process of any kind, you really need to talk to someone like our sales team here who knows how to assign the filter media that matches your application. So different fabrics out there have different temperature ratings, different resistiveness to abrasion and chemicals. There are various options for coatings for really fine filtration or higher efficiency filters. All those are options, and you should not ever just pick a bag that fits without knowing what it is, because you over temp it and it will fail, or if you have moisture in your system, something like that. So the right filter media is critical. The right fit, I'll just throw this out there because a lot of times we'll see leaks that are kind of hard to trace. Bag looks in good condition, but it's the fit of the bag on the cage and the tube sheet. It's not right. You can have leaks through there. So whenever we're quoting filters, it's very important that we get those dimensions right. There's some articles and blogs that Andy has put up on the website, and you can always ask one of our people for help so that we get the right dimension spec for your filter. And I think that's it for my slides there. So I'll pass it on to Dominic, I believe.
Thanks, Matt. All right. And that was a lot of good stuff there. So we're going over all those. There's a lot of really practical, deep dive, technical things there. We're going to change gears a little bit. This part, we want to talk about perhaps those that are responsible more for procurement, design, purchasing, big picture kind of stuff. And let's talk about getting a new system or a major revamp of an existing system. How do we avoid paying for something that's not going to work? Or how do we avoid overpaying for a system that we need? Well, I want to tell you a brief story. A long time ago, I went to a large facility that had several dozen dust collectors in it. And as we were doing the inspection, I remarked to the person taking me around that every single dust collector was a different brand, different filter size, A lot of them were bags, some were cartridges, some were envelopes, like every possible thing. It was like a baghouse museum in there. And I asked him, how in the world did you end up with so many different things? And he told me donuts. And I said, how did donuts mean this happened? And he said that that particular facility, purchase of dust collectors was done by project engineers. And he said that basically whenever a baghouse project would come up, dust collection project, whoever of the local salespeople that would stop at the plant randomly, whoever stopped in with the best box of donuts was the person that got into the meeting, and then the person who ended up selling dust collector, whatever brand or whatever thing they had to sell. So the different engineers always bought them. So basically, the choice of dust collectors they had was based on kind of donuts happened. So it goes to show that sometimes we're our own worst enemy when it comes to selecting the kinds of systems that we want. Whether we pay too much or we get the wrong kind or a little bit of both, how can we avoid that kind of situation happening at our facility and projects that we're managing? So if we go to our first slide, you'll see we have a few things we want to educate you about that'll help you make sure you don't have this kind of situation happen to you. But all of it has to do with doing your own homework. So you educating yourself before the process starts is the key to making sure you get the system that you need, the system that you want, and that you pay a reasonable price for it. So let's talk about a couple of these concepts as we go through, and you'll see what we can research and why it's important. So the first one, if we go to our next slide, is airflow. So airflow through the system is the whole reason we have the baghouse, right? We're looking to move a certain amount of air that's contaminated with dust and filter it. So how much airflow do you need? How much CFM, cubic feet per minute of air, does your system need to handle? Well, in general terms, the larger the space that you're trying to vent, or the greater number of pickup points or drops that you have on the system, the more airflow you're going to need. Now, the airflow is generated by the system fan, as you know. So if we need more airflow, we need a larger fan that can generate the required airflow to handle all of our different pickups. And then we take the amount of air and the kind of dust application, other factors, and then we have to find the dust collector that's the right size for that airflow and the application that we're doing. Now, something to think about, if we don't have enough airflow, what happens? It's not that the baghouse either works or it doesn't work. It's not a light switch. What happens is you have a baghouse that can work really well, okay, not so great, poor, and then you have one that just works terribly. So most people may have only ever experienced a dust collector that works poor or maybe okay. And for them, that's their concept of how they work. Other people have only ever seen like the greatest dust collectors ever, and they're designed really well in size and think they're always perfect like that. But a lot of this comes into having the right airflow. If we don't have enough airflow, as we see at our pickup hoods, what happens? It's not that all of the dust falls out and it's all over the floor. It's usually that the system collects some of it or most of it and then leaves dust around the pickups. Or maybe there's fugitive dust that floats away and then goes and settles elsewhere in the facility in the nearby area. That's what not having enough airflow looks like. Or we have a lot of buildup in the ductwork because the material doesn't move fast enough because there's not enough airflow. We'll talk about that one in just a moment. But that's why it's important to have enough CFM for the system for what you're planning to do with it, whether it's a pickup hood, whether it's a process that's plugged right into it, venting a silo, whatever it is, you have to have enough airflow. And you need to know this more or less before you start talking to a dust collector vendor. Now let's go to the next slide. Our second thing you should have a kind of a concept of is static pressure and vacuum pressure, which really is, as Matt just went over, really just means the resistance and the suction you need. So the resistance is the resistance to airflow created by the pickup hoods, all of the ductwork, any items that go in the ductwork like combustible dust protection devices, valves, dampers, diverters, spark traps, and then the resistance that's created by the baghouse and then the exit exhaust stack itself. So all of those things together becomes the static pressure or the resistance, and it's measured in the same thing as the differential pressure in the baghouse, inches of water. And in fact, the differential pressure in the baghouse is just the measurement of the static pressure the baghouse creates or the resistance it creates in real time. So generally speaking, the baghouse is the only thing that changes the resistance. Whether the filters are dirty or clean, the resistance it makes goes up and down. The ductwork pretty much stays the same no matter what you do, unless you change how much air is going through by a lot. So that's why we monitor the differential pressure a lot. Why does this matter for when you're selecting the system? We're going to ask for quotes. Because when you size the fan, you need to know how much resistance you have to overcome to get the right size fan. Sometimes people think that it's just that this fan does 10,000 CFM, this one does 20, this one does 50. But actually, it's not just the airflow. If you read the full spec, it's 10,000 CFM at this static pressure, 10 inches of static pressure. And as Matt explained, what does that mean? It means that when there is 10 inches of static pressure in front of the fan, so all the ductwork, the baghouse together makes 10 inches, this fan will create 10,000 CFM of airflow through it, right? And that's a simplification of how fans work, but that's the basic idea we want. This is important when you're procuring a system because when you write your spec for what kind of fan you want or how much airflow you need to tell the fan supplier whether you need this much static pressure or a lot of static pressure. So if you're just if you have one short little run of duct with one pickup hood, you probably need just a little bit of static pressure on the fan, or vacuum pressure, sorry. You need just a little bit of vacuum pressure to overcome that resistance. Whereas if you have a big spidery system with lots of little branches or really long runs of duct, you need to make the fan have a lot of suction on it to overcome all of that. And the difference between a fan that does 10,000 CFM at 10 inches of resistance versus a fan that does it at 25 inches is enormous in the cost, the power, how much it costs to operate it. So it's really important if you're trying to get that apples to apples comparison, or just the one that you need, not undersized to make it cheaper. You need to call that out and have an idea of what's required before you submit the project out to get bid on. All right, if we go to the next slide, another thing you should have in mind a bit is air velocity and the minimum conveying velocity for your application. This is especially important when you're talking about the ductwork design. So some users might design the duct themselves. Sometimes they hand it off to the dust collector supplier, or they might hand it off to an engineering firm or third party. In our case, for example, at baghouse.com, most of our customers ask us to design the ductwork system as part of our package. And we're able to do all of that together. That's one of our benefits of working with us. You can do the whole complete pickup hood through ductwork to the collector, the fan, design the whole thing as one big package. But in any case, it's good if you have a general idea of the velocity that you need for your system, because there's two problems. There's the problem of having too high a velocity and then having too low a velocity. If the velocity is too high, you can wear holes in the ductwork because the material is abrasive a lot of times. So you blow out the elbows. You can also waste a lot of energy, power, because pulling something too fast through the ductwork, faster than it needs to go, it very quickly becomes very energy intensive. So you don't want to move it faster than it needs to go and be wasteful. It also, in certain applications where you're conveying like a finished product, like some food materials, for example, moving it too fast can cause it to break up and cause a wear and other effects like that we want to avoid. But more importantly, or more often, low air velocity is the problem we want to avoid. So you have our picture here. Every material that we work with has a certain velocity that it needs to move at in order to stay floating in the air. So if you have a heavier material, if we have flour versus lead dust, it's going to need to move faster. But also if you have big pieces versus small pieces. So a grain of lead dust is actually not heavier than a big chunk of wood that's getting sucked through the system, right? So the bulk density of the material, but also how big the particles are, what exactly you're moving. All of that goes into determining what's called the minimum conveying velocity. That's the slowest possible speed that you need to move the material so that it stays floating in the air. If you go lower than that at any time, what happens is what you see in the picture, where you have the dust builds up in the bottom of the pipe, and then you get all kinds of other knockoff problems. You get restriction, because now the pipe is smaller inside, so it actually speeds up the air, causing abrasion after it. You also get where it can create more resistance, so it lowers the airflow through the whole system, it plugs it up. And in the case of if you're handling combustible materials, these become especially hazardous because any spark or ember that you suck up could land in any of these accumulations of dust and then start to smolder, create a fire or an explosion. Or if there's an explosion or fire somewhere else in the system, if it propagates through the baghouse and the ductwork, when it finds these large pockets of material, it'll dislodge them and create a much bigger explosion, fire that's quite hazardous. In fact, most really devastating dust explosions happen not because the baghouse exploded. It usually happens because the explosion goes backwards and finds these accumulations in the ductwork. So having a general concept of what velocity you need to move things at will help you when designing your ductwork to make sure the system works well. In general, just for your knowledge, in general, most materials for our purposes are between 3,500 and 4,500 feet per minute. Some need to go a little faster, some can go a little slower, but that's generally the range that we work with dust collection. Okay, let's go to the next slide. Now here's a fun one, air to cloth ratio. This is our shorthand in the industry for sizing the baghouse. Many people will ask us, I need a 10,000 CFM baghouse. Or you might even see listed a lot of times for used equipment. People will list it and say, this is a 10,000 CFM baghouse. This is incredibly misleading because there's no such thing as an airflow rating for a dust collector. Why is that? Because how much air that dust collector can handle is entirely dependent on the application. If you are collecting a little bit of welding smoke in a shop, it is completely different than if you are collecting frac sand from a giant dryer and moving tons of material per hour through the baghouse. Completely different. So be wary of anyone that tells you this unit does this much. They should always tell you this unit in this application with these specs can do this much. That's how it should be. So you need to have an idea of roughly the air to cloth ratio you should have. So in most cases, we want to do with pulse jet baghouses, something like 4:1 to 6:1. You can go a little more than that. Sometimes you can go a little less than that. But generally speaking, the more dust you collect and the harder the dust is to collect and remove from the filters, the bigger the baghouse needs to be. So bigger meaning the number of filters and the surface area of the filter. So that's what our slide here says. We do the air to cloth ratios. We take the airflow in CFM and we divide it by the square footage of the filter media. So for example, a normal baghouse with 6-inch bags that are 12 feet long, those bags have about 18.8 square feet of filter area on each bag. So you calculate how many bags you have, you get the square footage, and then you take the airflow you want and you can get that ratio. Different collectors have different ratios. So cartridges, for example, are much lower, like 2:1 or even 1:1. You might see also some reverse air rotating jet collectors go higher, or bin vents, for example. The reason you need to have kind of a number in mind, and you can get this by researching online, like on articles on our website or by talking to a consultant, is because the number one thing people will do to sell you something is tell you that their dust collector can do the same amount of airflow as the other guys, but be half the size. And obviously the reason they tell you that is because then theirs looks cheaper and you want to buy that one. But the result of that is that you get a system that's undersized, which we'll talk about a little later what that looks like. But it's not going to be that baghouse that works excellent. It's going to be that baghouse that works meh to not so great to horribly. So having that in mind, that range that you want, will help avoid that. Also, it's good to know what this is because if you're looking at multiple bids from different vendors, you can compare very quickly the differences by seeing what the relative sizing is of the different collectors. Because if they use different size filters or configurations, it might be hard to see why the one that has 100 filters is a better option than one that has 150, but they're smaller, for example. Okay, let's go to the next one, Andy. So our last one we'll talk about real briefly is the type of collector that you need. So Scott mentioned this a little bit earlier, right? We have things like cyclones and stuff like that. That really, for most people, we're not going to be able to use as the final collector. We might use a cyclone or a knockout box to lighten the load or for some other reason going before it goes to the bag house. It's not going to be the final collector. But when it comes to our fabric filter collectors, our bag houses, cartridge collectors, and then even what kind of bag house we use, there's a lot of different options. And this is where a lot of people get in trouble. This is where we get the box of donuts problem. Because many people who sell dust collectors, unfortunately, are not very qualified to do so. So obviously, we think our brand of bag houses is the greatest, most amazing thing in the world. And it is. But there are a lot of other vendors that are very reputable that make really good systems too. But a lot of the people who sell dust collectors besides them, a lot of them are sales rep organizations, and the people that you might interact with don't really know everything about dust collectors. Or they're not trained, I should say. Nobody should know everything. More accurate is to say they're not really experts at dust collection. Or another common problem is they might only rep a certain supplier that only has one kind of system. Maybe they only make this kind of bag house, or they only make this kind of cartridge collector. So naturally, as all good salesmen will do, they'll try to sell you the thing that they have because that's all they've got. And they'll tell you everything that's good about it. You're not really getting the full picture, though, if you deal with someone that only has a limited product range. That's why a lot of companies like us and some others, we make all different kinds of bag houses, dust and cartridge collectors and things like that, because we know that one doesn't fit everything. So just having an idea of what kind of system you need will do a lot of good for you. So for example, bag houses, we like to say, are kind of like the pickup trucks of the dust collectors. They're rough, they're hardy. You can tow a lot of weight behind. You can drive on the road. If you get the big one, you can have a lot of people inside. You can do it pretty much anything with a bag house. Now, cartridge collectors, though, offer a very good alternative sometimes because they're smaller, more compact. So they're cheaper to make, cheaper to run. They're a little bit easier to work on, changing filters. They're really good for applications where you have a light dust, or maybe you have a lot of air you have to move, but a little bit of dust. Think like a welding application. You gotta move a ton of air from the whole building, but only a little bit of dust. If you had a bag house do that, it would be huge compared to a cartridge collector. So a cartridge collector, they're great. We use them in a lot of applications, but they're really more like a van, like a minivan. If all you're doing is moving a little bit, a small group of people around all the time, it makes more sense to have a van than to have a big pickup truck, right? But you would never use the van to try to pull a big trailer to go off-roading, right? It just wouldn't work. And the same thing happens with cartridges a lot of times. They get stuck places where they have no business being, either because it's the only thing the sales guy has in his rep, in his thing that he reps, or because everybody else wanted a bag house and he wanted to be cheaper, so he tells you can use a cartridge collector. You also have the option of pleated filter bags, which are kind of a mix between the benefits of a bag house and the benefits of a cartridge collector, kind of like an SUV, right? So they have some of the benefits of more filter area like the cartridges, so the bag house is smaller, but they're not so tightly packed like the cartridges. They're more like bag houses in that sense, where it's a bigger, easier for the dust to fall off. So you can use them in a little bit more difficult applications that a cartridge wouldn't use. And then the only other one I'll mention is just the reverse air bag houses, the rotating arm reverse jet. They go by a bunch of different names, but these are the ones with the big cylindrical bag houses. And they have the rotating arm that goes around, pulsing back into the bags at all times, kind of a combination like a pulse jet and a reverse air bag house. These work very well for certain applications. They work really well with things like grains and sometimes sand and wood applications. But in other applications, they do not work well compared to a pulse jet bag house. And depending on how you compare them, it can look like they're a much cheaper option, but they're really not going to work anywhere near as well as a pulse jet will, which is that, again, that heavy duty big truck that's going to work really well. So having an idea before you get started of what kind of dust collector you need is going to help you avoid falling into that trap. Now, just in conclusion of this section here, what are two things that we want you to be aware of? Well, first is find someone that's a trustworthy OEM to design and install your system. Or another way you could do it is have an engineering consultant or an OEM work as your consultant and help you develop a spec that you can use to then go out for bids. This helps avoid a lot of those conflicts of interest, but it also makes sure that you're getting someone that's designing your system that has access to all the different kinds of technology available, not just pigeonholed into one particular model or brand of dust collector and then trying to make your application fit into their little box. No, have access to everything so you get the system that you need. Now, one other thing we want to tell people to be aware of. Go to the next slide, Andy. Beware of claims about miracle solutions. This happens all the time where we work with a customer and they say, oh, well, we were told that this new technology was the greatest and the best thing ever, and that we could do 3 times the volume and it would be half the size and half the cost. So just a few things we tell people to think about. When you hear things like that, think for a moment, if it's really that great, why doesn't it dominate the market? Why isn't that technology the market or industry standard? Why doesn't everybody else imitate or copy them if that's the case, if it's so great? A lot of times companies will try to use a old idea that's been discarded by the industry or come up with some novel idea. They change the shape of the cartridge slightly, for example, and then they say that it's amazing. A lot of times it's just because they want to stick you with something that's a proprietary design. You know, it's like Gillette selling the razor at a loss, and then the cartridges that they sell you, they have a huge markup on. That happens quite a lot in dust collection. Other times they have things that might, it's great, try new things and new shapes, new types of filters. They might work well in lab, but in the real world, we know from experience they don't work very well. So they should keep trying to invent new things, but want to make sure that we don't get stuck with that. And then the second thing, if we go to the next slide, Andy, we just want to make sure to avoid getting solution. I thought we had one more. Okay. Well, just one other thing with miracle solutions is make sure you don't get a system that's undersized. As we said, when you get comparative quotes, try to make sure it's apples to apples. And the main thing to watch out for is if somebody's trying to give you a more aggressively sized system, claiming that it'll work fine. It'll work just well enough that you can't sue them afterward and say it didn't work, but it's not going to work as well as the one that's properly sized. So look for those things when comparing. And in all of this, in summary, we can just say educating yourself beforehand is the key to avoiding these problems. So you're not going to learn everything. You're not going to become a dust collector expert, but being an informed end user, informed consumer, having this nice general knowledge of these few key areas, it's going to help you look for the important things on those proposals that you see. And it's going to help you avoid overpaying for a subpar system that's not going to work and not deliver the performance that you need. So as I said, we educate ourselves to an extent, but we need to when we're coming up with a system design or running that kind of project. But learning about dust collection can have a lot of benefits, whether you're from management all the way down to technicians, engineers, environmental and safety people. Whatever it is, learning more about dust collection really does benefit your organization, your plant, and your individual employees on many, many levels. So let's hear from Andy now. We've got some exciting news about training programs that we offer and some new developments we want you to know about.
Thank you, Dom. And it's you guys all did amazing with your parts. It's amazing how in a very short period of time we can learn so much, right? And it's knowledge that will enable us to choose the right kind of dust collector, but also be familiar with the components so that whenever we need to give it maintenance, we have the tools, right? And there's no better tool that having a team that knows each part of the dust collector and how to troubleshoot it, right? And so throughout the years, Baghouse has seen how the customers or the people that invest the most in having their personnel trained, that's the companies that do better when it comes to production, when it comes to having efficient systems that run for many, many years. And so having that in mind, we compiled all those years of experience in baghouse.com helping customers, and we condensed that into a training course. Now, we've had training course before, mostly in person, that many companies hire with also an audit, a system audit. But now we have a training course that is online, right? We spend 2 years putting it together, uploading to our website so that everybody can benefit from all that experience. And it really goes from the basic to the more complex subjects in dust collection. But that's the thing, like this slide says, no dust collection system runs efficiently without someone that knows how to maintain it. So when we educate our personnel, then we will save a lot of headaches. And our investments, which is dust collectors and all the time and efforts and resources that we spend trying to get that dust collector will last for a long, long time. And so here there's a little preview of this course. Let me see if I will share screen. So that you can get like a little preview of the different options that we have when it comes to training. So let's see.
At baghouse.com, we understand that every business has unique needs when it comes to dust collection training. Our training course has 8 dynamic lessons that cover everything from the basics to more advanced design concepts. Everyone can benefit from this training, no matter what application you work with. This course is interactive and practical, with detailed explanations from our experts. Many of our customers have expressed how this course has given their maintenance and engineering staff the troubleshooting skills to fix common issues. It includes real scenarios and case studies of the most common challenges and advice on the best practices for your industry. For environmental health and safety personnel, there is a special lesson aimed at understanding the regulations of this field and how to apply them in their own companies. That's why we offer 4 flexible training programs to fit your team's schedule and learning style. In-person training. This option combines a hands-on inspection of your dust collection system with an engaging class led by our experts. Virtual training. Join a live instructor on Zoom for interactive sessions designed to address your specific concerns. Online training. Learn at your own pace with our self-guided courses. This option allows you to access expert knowledge anytime, anywhere. Combined training. This unique program blends self-guided online learning with live Q&A sessions. Enroll now and train your team on dust collection best practices.
Very good. So as let me see. As you saw, there's different options
At baghouse.com, we
technical problems. There you go. That adapt to the different circumstances and different schedules of our customers or whoever is interested in the field of dust collection. And so as we saw, we have 4 options, but now we're going to focus on this new one that we're releasing, the online training course. In the past, we've done virtual training and in-person training, but this one is new because it's self-guided. You can enroll and you have a student dashboard. You can go lesson by lesson. The lessons have a quiz, questions and answers at the end of each lesson that really makes all the content, all the theory, and also the videos that is better for you to remember afterwards, right? This online training, we are doing the free trial, which is the lesson number 1. It's for free. You can take a look at it and see how is the dynamic of the class. And also for the ones that really like it and want to buy the subscription, you can buy the whole online training, which is 6 lessons, 2 additional supplementary lessons, the appendix, and also, well, a bunch of downloadable materials. How do we enroll if we're interested? Well, if you go to our page under services, you have our training program, online training, and then you can enroll. You can sign up and log in with your credentials, and then your student dashboard will be there with all the lessons. And you'll be able to track your progress as well. So it's it's a really neat course. You can take it in the time of day that you want, in your cell phone as well. It's very flexible. And let me see. Well, that will be it. So if you have any question about this training course, one thing that we wanted to share is that if you attended this webinar, at the end of this webinar, we're going to give you a discount code in case you're interested in this training course. We're going to give you a 20% off on the cost of the training. So that's really, really cool. And it's aimed to the personnel, as we've seen throughout the course, purchasing, operations, the engineers, everyone can enroll in this course and get the most out of it. So we now move on to Matt. He has the last part, the closing comments.
Yeah, so just to kind of recap, thank you, Andy. You know, this online course has been a long time coming. Several customers have asked for it, you know, consistently for over a year now, and now we're happy that we're finally able to release it. So it's really exciting. A lot of good stuff in there. I mean, it's like distilled experience from our entire team, and hopefully it gives you an option to train your staff and people in a way that's convenient. We've tried to make it very cost effective, and you know, everything that your people need to know should be in there. We get a lot of requests for training, but there's only one Dominic and one Scott, so we can only fill so many slots with on-site trainings. There's a lot of people out there with entire staffs of people who can benefit from this, and so we hope it, you know, we hope it's what you're looking for. I think Andy's probably going to follow up with an email with a link and some instructions and stuff, right? So you should have that in your inbox here pretty soon, just to make it easy for everyone. But yeah, thank you all for your time. We're going to go through a couple of Q&As. Some people submitted specific questions prior to the webinar here. So I think Dominic's got the list. We're kind of going to just do an open roundtable here, and he's going to fire off some questions, and we'll do our best to give you answers here for those who want to hang on.
Yeah, so we tried to organize some of the questions that kind of overlapped and put them kind of in groups of ideas, things like that. So we'll see how many we can get through here before we conclude. So one of the questions we had a lot about was when we're looking to get quotes and buy filters, there's a lot of confusion about sizing, measuring, things like that. How do we use the term diameter for the bag? Some people call flat width. Some people don't understand the difference between the diameter that is the tube sheet hole size, the bag diameter, the cage. So what can we say there, Matt? How do we define when somebody asks us to get a bag and we tell them we need the diameter, the length, and the flat width? What do all those terms mean?
Sure. So the first thing to know is if you're not sure, you can ask whoever you're interacting with here in our company. If it's Andy or Scott or Dominic or myself or Dave, if you're not sure, we'd be happy to explain it to you. But just to do a kind of a quick and dirty answer there. So the diameter is just that distance across the circle of your bag or your cartridge, which you can measure directly with a tape measure, or if it's a fabric bag, it might not be that easy to measure. So what we ask you to do is lay it flat, take a tape measure and measure right across that width, which is the flat width. And with that, we can calculate the diameter. The length, typically we'll ask for the length from the bottom of the bag to the top, or the snap band where it snaps into the tube sheet. Pretty straightforward there. You just lay the bag out on the floor and measure with a tape measure. Occasionally there's some other dimensions we need. The best possible scenario is if you have an extra bag, you can just send it to us. That way we can get it to the filter shop and let them match the snap band diameter, the width, the flat width, all those things. You know, if you send your bag over here to Scott, he can take those measurements for you and we can confirm it will fit, because some of those measurements are easier to take than others. Did I answer the question?
Awesome. Yeah. There also were some questions too about when we're talking about snap band bags. There's some confusion between diameter of the bag versus the tube sheet hole diameter, or they don't know what the tube sheet hole diameter is, and is it the same as the diameter of the bag? I don't know, Scott, maybe you could tell us what's the tube sheet hole measurement and why is it so important for us?
Yeah, so you can kind of see in the diagram of the bag house drawing that's on the screen here. We can't hold a bag perfectly in a circle. So it's very difficult to be able to take a very accurate tape measurement of our bag. So one thing that will go off, especially if it's a snap band style bag, which is one of the bag styles that we have for a pulse check bag house, is we'll ask you for, with the calipers, the diameter of the tube sheet. That's where the bag will snap into the metal plate that divides the clean and the dirty side of the bag house. So you can kind of see that there. Some people call it a different name, like a cookie sheet or where the bag snaps into. We usually call it the tube sheet. We'll need to know that measurement as well. We want to make sure that we get that exact measurement. If it is a little bit too small, our bags will then leak. They won't be able to perform or have a perfect seal. If our bag is slightly too big, it'll actually have like a little crease and won't be able to snap perfectly into that tube sheet again, causing leaks, things like that. The other option that Matt had said is that you can send us a bag as well, and we can make an exact replica. If we're unsure about the tube sheet diameter, like maybe we can't actually get in there because the bag house is running 24/7, or we don't have a dirty bag to send, we can actually send you a sample, a pre-production sample, to be able to put the bag in there, make sure it fits well. If it doesn't, adjust it slightly and take it from there. But we want to make sure that that diameter, that bag snaps perfectly into the tube sheet of the bag house.
Awesome. And I think I'll just add, there was some questions too about sizing the cages. So when we have a snap band, a pulse jet bag house, the top load that uses snap band bags. Obviously, the cage fit is important. So it's really like a series of things we have to size. So the very first thing is that hole size, right? We get that hole size. For example, our collectors and a lot of other major brands, we use a industry standard 6.25 inch tube sheet hole. So that's our biggest part. And then we have our bag, which has to be a little bit smaller. So that's usually 6 inches or 5 7/8 actual diameter of the bag. And that works out to about a 9.25 flat width. And then from there, now we need the cage, which needs to be smaller than the bag to go inside, right? So the bag diameter or the cage diameter is usually about 1/8 to 1/4 of an inch smaller than the bag. So a very common combination. This is what our units use. A lot of other brands is 6.25 inch hole, a 5.875 diameter bag, and then a 5.625 diameter cage. And that gives us that nice like 1/8 inch, 1/4 inch, what's called pinch, or how much you can pinch off of the cage. So whenever you call us to ask for a bag quote, those are the measurements we're going to need. And sometimes it might seem like we're asking for more and more. That seems unnecessary, but it's because a lot of times there's like, what do we call it? We call it size creep, where over time everybody measures it a little bit more sloppily. And slowly people get bigger and bigger bags or different mismatches between the cage and the bag. And how tight that bag is, the cage, is really crucial for the snap band, the pulsing. I'm sorry, for the pulsing action. When it pulses, the bag snaps back on the cage. It's really important that distance, that's oversizing of the bag, be right in the range it needs. Otherwise, the cleaning won't work well. So we might ask you to verify the cage diameter. And if we do that, we're going to ask you to measure it in the body of the cage, usually not at the very ends, because some manufacturers make the cages get just a little bit smaller at the bottoms. So that way we can make sure all of those things line up in the right sequence, from the smallest, the cage, to the next size up, which is the bag, to the tube sheet hole, to make sure everything is all matched together. Okay, well, thanks guys for those answers. Let's go into another one. We talked about this a little bit in the briefing, but maybe just real briefly, Matt, what would you say? Somebody asked about what's our average lifespan for a bag house filter versus like a cartridge or a pleated bag. What would you say average lifespan should be?
Well, the sort of kind of semi-answer I usually give is that a rough middle of the road estimate of about a year is fairly reasonable, but of course it depends. So the fully lawyerly answer is that it depends, right? So Like I said earlier, if you're running it hard, a lot heavy dust loading, 24/7 operation, abrasive dust, temperature spikes, all the worst things you can think of. If you're throwing the whole kitchen sink at it, you might have to change your filters every 2 weeks or every month. It really just depends. If you've got, your sort of wood shop, tool shop that gets used once in a while and it's getting some light, fluffy dust and used once a day or so, heck, those filters could last for several years. It really just depends. You're really going to want to talk to someone who can take a look at your application and your system sizing and all those factors and figure out what the best filter is for the application, and who can probably give you something like a better estimate of how long you can expect the filters to last.
Excellent. Yeah, it also impact too is if the system is undersized or not maintained well, then that's gonna shorten the lifespan of the bags quite a bit. Yeah. Kind of along those lines, we had some requests, some questions that came in about how to identify damaged bags. So what solutions are there for finding bags? A lot of people wrote in saying, when we have a leak, it's really hard, takes a lot of time to go find the leaking bag. How do I find a leaking bag in the midst of hundreds or thousands of filters? What would you say?
So the easiest way is to do a dye leak test. It's very simple. I understand not every customer can do that. Sometimes if you're recycling the dust out of the hopper and it's going into your product, you may need to look closely and see if that'll work for you. But for most people, they can. Basically, you just take this powder, which is colored powder. It shows up under UV light. So you suck it into your bag house. You can introduce it through the upstream ductwork and let it coat your filters. Let it run for a few minutes, then you shut your system off. You go into the clean air side or the clean air plenum of your bag house with the UV light, a black light essentially, and you basically play detective. You run it along until you find the indication of that powder where it's come through the filters. And usually you'll find that there's the filter. You can identify 2 or 3 spots. Sometimes you'll see around the interface between the filter bag and the tube sheet, there'll be a little indication. So that's definitely much easier than trying to track and trace a leak based on signs of dust in the clean air plenum, which can be swirling around in there. It's nearly impossible most of the time. So the leak test powder is the way to go. You hit the clean air plenum and find them that way. You can also go into the dirty air side, and sometimes you can see where the dust has collected onto one particular cartridge. Say if there's a really big leak, you can see that everything wants to go to that leak, so it'll be coated with that UV powder stuff, and you can pick it up pretty easy. It is important that you have good light, high wattage light, the darker the better. So if you can enclose yourself into the clean air plenum using obviously appropriate confined space entry procedures and everything, but basically you just want as little light as possible so you can see that stuff under the light.
Yeah, me and Scott just came from a customer where they were having problems finding the powder, and we recommended that they go on the dirty side sometimes when there's a difficulty finding it. That sometimes is the only option. It's better to be on the clean side, but sometimes you need to go on the dirty side too with the light. And I would just add sometimes too, not enough powder is used, right? We've seen that before. And follow the calculations, roughly 1 pound for every 1,000 square feet that you have. And then that makes sure you get proper coverage, and also where you inject it, right? Inject it upstream of the bag house if possible. If you're in a pinch, you can put it into like a hopper kind of injection port on the bag house, but it's much better to put it in the ductwork so that it distributes, evenly everywhere. Somebody asked too about monitoring for emissions, and it kind of goes along with this, there are different ways to monitor what goes out of the stack. But the best one is what we call triboelectric emissions monitors, or sometimes just called triboelectric leak detectors, because that's actually their main purpose is detecting leaks. So the dye testing is like the maintenance way of doing it. The tribo detectors are sensitive enough that they can tell you when a leak is starting to form in the unit far before you'll see something coming out of the stack. They'll let you know that it's starting to rise. But also on larger systems, they can be really useful for locating the leak down to a specific compartment or even down to a specific row of bags. When it's pulsed, that row, you'll see a big spike on the triboelectric detector, and that's why we call them a leak detector. And then it narrows it even faster and even more precisely to just one specific row of bags where you know you have your problem. So a lot of people use them for the maintenance reasons. You can also use them for the emissions monitoring as well. But those two things together, the bag leak detectors and the dye testing, that's really the gold standard for how to find a leaking filter quickly. Related to that, we had some questions about changing bags and damaged filters and things like that. Something that comes up a lot that we talk about is spot changing. So that's where you have one leaking filter or maybe a few leaking filters in a bag house. And as Scott mentioned his part about the nail in the tire, what do we do? So we usually recommend you obviously have to change that filter. We can't leave it leaking. But Scott, maybe you can tell us a little bit, what's one thing we have to be careful of when we're spot changing filters in a larger system? What do we want to avoid doing too much of?
Yeah, we definitely want to use it as the exception and don't, let it become the rule. We talked a little bit about in that section the dust cake that naturally forms on the filters. A little bit of dust, a little bit of buildup on your filters is, actually very good. Why we don't necessarily need to only have clean, pristine filters on the dirty side is, if we do spot change our filters like that, a lot of times it will change the airflow, for example, how the air is going through from the dirty side to the clean side. And obviously, if we have a nice, clean, pristine filter, more air is going to naturally go to that filter than the other filters. So essentially, spot cleaning, again, we only want to use it as an exception because essentially we're going to wear out that new filter so much faster. Wear out that filter, we have to change it, we have to change out this, we have to change out that. It just becomes a vicious cycle of we just need to change out all of our filters to be able to, make sure the baghouse is functioning correctly.
Yeah, exactly. We actually say a lot of times it leads to like cascading failures, right? If you keep doing it. So it's kind of like the necessary evil, like it's like putting the spare tire on your car, right? It's there to get you to the mechanic so you can put a real tire on, but you can't drive at full speed. It's going to fail. If you try to just drive around with one little dingy tire and three big normal tires, right? It's going to then cause problems, right? Another question is one more on filters here. Matt, somebody had asked, we've talked about early filter failure, when we need to change those filters. How do we know when filters reach the end of their life and we have to change them? What are the signs that the filters are blinded and at the end of their life?
So this question is right out of our Baghouse 101 training materials, right? So what the most fundamental thing we look at to evaluate how a baghouse is operating and how it's running is the differential pressure. So you will see over time the DP gauge will go up and then it'll go down as the filter cleaning system kicks in, right? It'll go up and down. And if you're plotting it on a graph over time, you'll see this sawtooth. It'll slowly over time go up and down, but it'll trend upward. In a certain point, your filter cleaning system will no longer be able to adequately clean the bags because it's got those entrained particles that just aren't being released with the pulse air. And that's a sign that it's becoming blinded. And there's a certain point where it'll be up at a high differential pressure and the cleaning system will not be able to bring it down to your desired set point. So maybe it's up at 6 inches, your cleaning system's struggling to get it down below 5. There's a certain range and it's going to be dependent on your system and your application, but that is the metric to use, your differential pressure. When it gets to that high point, it's time to change your filters.
Yeah, good explanation. And like we said too, sadly, there's a lot of facilities where people have never even seen that, right? Because for whatever reason, their filters are always getting holes and stuff like that. So they've never even experienced that where it's at the end of their life. Some of the larger applications where they have big reverse airbag houses, they're able to plan this out months, even years in advance because they're carefully watching the differential pressure. They have it all trended. And they even monitor also the emissions coming out, and they can predict pretty accurately on those kinds of systems months and years when they're going to fail. And that's how they can schedule those change outs at a convenient time.
Can I add, Dominic, just one or two quick other things? So on that point, most of the timer boards that are, they come along with your baghouse in this day and age will have a differential pressure readout, like a digital readout. And it's important to make sure that you're getting good readings. The way those work is very simple. It's just two air tubes. But if they get blocked up or the tube cracks and you get an air leak, your differential pressure reading, which is your most fundamental baghouse safety, health measure, may be not reading correctly. So I always point out to people, number one, make sure that you're maintaining those air tubes and you're testing the DP reading, either with a separate gauge or there's a couple little tests you can do. And then one other thing, most of the timer boards out there nowadays also have an analog output. So you can run a 4 to 20 milliamp signal to your control room or wherever you want it to go. So somebody can pull up a report or log that or check it. You can signal an alarm. There's a lot of stuff you can do. Just the basic Dwyer boards that you can find, the turbo boards all have that analog output that you can send to your control room. So you can do that trending and analytics if you have the desire to do that.
Yeah, that's a good point. Thanks, Matt. Let's talk a little bit about cleaning systems now. Somebody asked this question. They talk about the specifics of the cleaning settings. They said, what is the proper compressed air pressure for bag cleaning versus cartridges, their difference? And then what about the things like the on time, the off time, the cycle timing? What would you say, Matt?
So there are some differences. So general recommendation, I usually look for 90 to 100 PSI. There are a couple of OEMs out there for cartridges that run a little bit lower pressure. So, check your OEM manual, but if you have 90, 95 PSI, you should be just fine for a bag house cartridge collector. You're in the right range. As far as timing, that will kind of depend on your application. So whoever you buy your system from, you should ask them. They will probably come pre-programmed based on your blowpipe and your pulse valve size. The actual open time for that will be determined by that. So whether that's 20 milliseconds or 100 milliseconds, it depends on the diameter of your connecting, your blowpipes and pulse valves. The downtime or the wait time, that will kind of depend on how heavily loaded your bag house is. If it's not uncommon, we'll go do an inspection and we'll hear them pulsing every 10 seconds, which is too fast for almost every application. It's maybe just a default setting on the Dwyer timers or whatever it is. Like I said before, I think clean on demand is best. So you're not activating your system until it's needed. But there are systems out there that don't have that capability. There's no pressure module, so it's just a timer. And I would say, again, just to throw a middle of the road answer, 20 to 30 seconds, is probably on the low side, maybe even higher. But you're going to need to look at how your differential pressure is responding. If you're getting high DPs, maybe your cleaning system timer should be tightened up a little bit so you're getting more pulses.
Yeah, I would just add to that that off time, the on time is one of those things. It matches the valves, and then you should never touch it. But sometimes people have the mistaken idea that if I open the valve longer, it'll make the pulse more powerful, and it actually does the opposite. Because instead of a nice punch from the high pressure air coming through, you end up getting like a kind of weak, like kind of, and it doesn't really have that punch that gets the dust knocked off. And then the off time, how long it waits between pulsing. When you do have it in clean on demand, we get this question a lot. When you do have it on demand, it doesn't really matter how long it is. It should actually be quite short. It really just needs to be long enough for the air header tank to refill to max pressure between each pulse. But as long as it's got enough time to do that, the shorter the better, because when the clean on demand starts, you want it to clean as fast as possible and get its job done and then stop. It's not really controlling how much you clean when you have it in the clean on demand mode. It's just how long it lets the valve or the tank refill with air, right? So if you have on demand, the off time, not really all that big of a deal. Let's go to some questions about applications and system designs. We had a question here about filter bags, how we decide what's the best kind of filter for our application. Maybe Scott, could you walk us through?
Yeah,
We usually say there's I think it's 5 steps that we tell people
yeah.
that we go through to find the right bag. Can you walk us through those?
Yeah, we don't have a one size fit all approach. There's a couple of different things that we need to keep in mind when we look at our filter media or the fabric type. The first one that we would consider would be the temperature. Do we have a high temperature or a low temperature application? Low temperature would be anything generally up to 250 degrees Fahrenheit. High temperature would be anything above that, generally to about 500 degrees Fahrenheit. So we need to know what type of fabric can withstand those types of high temperatures if we have a high temperature application, for example. The second thing that we look at would be the chemical makeup of the airstream. Basically, what type of a dust is going through it? What material is it? Is it some sort of acidic dust? Is it some sort of alkaline, for example? We want to make sure that we take into consideration different things like humidity, the dust that makes it up, what type of chemical reaction will happen when it reacts with other parts of the dust collection system. The next one that we look at is the kind of dust size and the physical characteristics of the dust. For example, is it a dust that is sticky or abrasive? Is it a dust that's difficult to collect when it's moving through the ductwork or the airstream? Does it tend to stick together? So we need to choose the correct filter that will be able to handle those types of things. The fourth consideration would be our collection efficiency. So that means with our application, do we have to collect most of the dust, or do we need to collect absolutely the smallest of the particles and get nearly all of it out of the clean air? We want to consider those things, especially if it's hazardous or if it's a toxic material, for example. Maybe we work in a field that's very highly regulated, so we want to make sure that we're collecting as much of the dust as possible, even those smallest particles as well. And then the last consideration that we have would be the price. So we want to make sure that we can meet those needs of our application. And basically, what's the cheapest option? What type of media or fabric will be able to do all of those things for us, but be the most economical in the end? So again, as we mentioned, if you call us on the phone and you look for a different type of filter, or you don't know what type of filter to use for your application, those are the 5 things that we'll generally ask about. And with that, we can help you choose the right type of fabric media for your application so that the bakehouse runs correctly and you're able to, again, collect the most amount of dust possible.
Yeah, good explanation, Scott. Thanks. I would just add too, there's sometimes where we have applications where there's multiple fabrics and things that will work. And sometimes it's a cost benefit analysis. Or then in other applications, there's just alternatives or add-ons we can do. For example, we might add a coating or a treatment, perhaps that'll help with the dust release. We might add a coating like an oleophobic coating to help repel some moisture and oils that are in the gas stream. Maybe not this essential for operation, but can make things work a little bit better for a reasonable, uppage in the price, right? And then the cost benefit analysis can make sense there. All right. Matt, maybe you can help me with this one. We had a question about combustible dust and NFPA requirements for dust collection systems. So I know this is kind of a tricky one here. What would your answer be if somebody says, I want a dust collector that's NFPA rated? How would you what would you answer back on that?
Sure, pretty common question. So again, the lawyerly answer is you need to be familiar with your local requirements. So there's going to be a fire marshal, an OSHA inspector, whoever it is that your regulatory authority is the ultimate authority for your specific application. Now, that disclaimer aside, there's a few basic requirements for all dust collection systems handling combustible dust. Typically, that would be explosion vents or ventilation on the baghouse itself, some sort of isolation between the baghouse and the process. So an isolation valve on the inlet or the dirty air side of the baghouse. If you're returning air back into the building, you would also need to have isolation on that side. And then you would need to have some sort of an explosion rated or combustible dust rated discharge device, so like rotary airlock or an XP or explosion proof drum kit. There are different requirements for a few different applications. Like if you're a wood shop, you got NFPA 564, I think, or 664. There's some special carve outs and exemptions. So that's why I say you really have to, you should be talking with your EH&S people at your site, if you have them, and your local regulators, because sometimes they will have special carve outs and deals and grandfather clauses and whatnot. You as the facility owner and operator are responsible for complying with that. So we can point you to the NFP requirements and tell you what you need to meet those requirements. And we're happy to do that. We have a whole suite of options we work with through Boss Products. We're a rep for them. So anything you have that's combustible, we can help you be compliant. There's a lot of other little requirements that you might run into, like duct thickness requirements. You can't have really thin little spiral ducts in combustible dust applications, specifically between your isolation or bag house. We can help you be compliant with a lot of that stuff. So if you ask us to quote a system with combustible dust, we will probably include in the package a number of options, including the vents, the isolation, the explosion proof discharge device. But we will want to certainly have a discussion with you about what specifically your requirements are for your local regulations, so we can make sure we meet those.
Yeah, I think the takeaway there is that the NFPA is not the law. The NFPA is like the fire code, and then the local authority, where that may be, they're the ones that say what the law is for you. And that's why we can never tell you that this system is certified, because we can never possibly know what is required of every single jurisdiction, right? And that's why the end user is the one that has to make the final decisions, right? And I would just say too, right, we have sometimes multiple paths that we can take. What you outlined is what usually makes the most sense, right? That combination of devices. But for example, some applications, they might have a smaller cartridge collector. It might make sense to put it inside and then have something like an explosion chemical isolation or a flameless explosion vent, because then it would keep the dust collector inside. In that special instance, it might be more economical, more practical to do that because it's a smaller collector. Now, in a big collector, that would be extremely expensive. So the solution you outlined, where it's outside with the isolation valves and the normal explosion vents, that makes more sense. But that's why we also tell people we usually start at this, but then let's talk about the process, and then let's see what we can figure out is the best option for you, right?
Yep. And sorry, Dominic, just to add, so we typically there's no need to reinvent the wheel in most cases. So if you have a wood shop system, we're pretty familiar with what the requirements typically are. Spark detection and extinguishing systems. If it's indoor or outdoor, there's typically things we would do. So it depends on your case. There's a whole bunch of options out there, pieces of equipment, and usually there's a best way to do it, and it's been done many times before. So we would point you towards, the normal solution for your type of application.
Yeah, very true. Very true. Okay, well, let's move to another one here. We have here, let's go to maintenance questions. So we had some questions about what are the best practices for dust collector maintenance. I thought maybe if you want to just chime in simply, without going into great detail, but what are some of the most important things or the things that you see that we recommend most often when we go out to do inspections? What would you guys say?
Well, so we have a dust collector maintenance checklist, right? Which we've given out to a bunch of different people. And whenever I do these kind of things, I always like to deliver that checklist as just like a template, because every system's a little different. But the things that are on that checklist are pretty much the same regardless of your system. It's checking your differential pressure, listening to your pulse valves, doing occasional filter inspections, stuff like that. Checking the operation of your fan, belts and sheaves. If you have a screw conveyor, checking your chain drive and stuff like that. There's probably 20 or 30 different items that you can add on there, and you could break up between daily, weekly, monthly or quarterly. and yearly items, what's most important is that you have some sort of a checklist, because the problem that most people run into is nothing really gets done until it breaks. So that's a problem. So even if you have a very simple checklist, which is just do a visual inspection of your bag house once a week, that's better than nothing. We can give you a checklist that'll have very detailed items and it'll make sure that you're good to go. But having some kind of a program in place, some companies have really sophisticated maintenance planning software and stuff. Sometimes it's just a check sheet that's up on the wall in the maintenance shed. But some sort of a process that your people follow is going to be required if you want it to last for a long time. But yeah, stuff we talked about, cleaning systems, DP, just give it a once over.
Yeah, I like what you mentioned earlier about the DP gauges. It seems like a little thing, but it's so common. It's like on the template for us to make our reports. I've just saved the same language because of the 60 site inspections I've done in the last few years. Every single one, I've had a paragraph that is make sure the differential pressure reading is accurate. It's so crucial, and it's so often overlooked. And it's they get plugged, the gauges get fouled, and it needs to be, in some places it needs to be monthly, every 2 weeks, sometimes every week they need to blow those lines out. And I really like now we have our devices that we sell that are the automatic DP line cleaners. And my goodness, dude, those save money if you put them in, because then every few minutes they shoot air back in to blow the line out. And it saves so much headache. Only people would either do that or just make it part of the PM to check those gauges and get them reading. Because sometimes we go out, right? And we ask for the DP readings and we know the numbers are wrong because they've been either they're implausibly low or something, right? Or the gauge is broken. And it kind of hamstrings us with what we can do because we don't know the most important operating parameter of the dust collector, right? What's it running at? And it's not until after we leave, they fix it, and then they send us stuff. Then we can finally kind of make some suggestions and understand what's happening from what we saw, right? So I would say that one, there's lots of that are important, but that one, make sure that's done first, and then everything else you can do, kind of follows that. Okay, well, those are all good. Let's we had a question real quick, Matt. Maybe you can answer this one for us about the airlocks and the discharge problems. What are some common things we see with the airlocks, the hoppers, and all of that kind of stuff that cause problems?
So hopper flow problems are really common, and we can always spot them because you go out on site and you look at the hopper and it's all bang. You can see where they've taken a rubber mallet or a hammer and banged on the side. So it's all banged up and you can, okay, there's a discharge issue that they're dealing with. So a couple things it could have to do with the dust. If you have moisture in your dust and it sticks to the walls and bridges, that can be a problem. So that should be addressed separately, but more specifically to the discharge equipment. So if you have a rotary airlock, for example, the idea is that you have a leak-free, airtight piece of equipment that provides an airtight divider between the hopper, which is at a certain pressure, and the atmosphere below the hopper, which is at regular standard atmospheric pressure. What can sometimes happen is your rotary airlock, which is a little rotor, it has tips on it, sometimes made from different materials, but they're designed to have a really tight clearance to maintain that leak-free, airtight operation. So the dust falls through, but the air basically stays at its pressure. When those tips wear out, air rushes through there. It becomes a leak source. So now you have air that's coming through your rotary airlock in the wrong direction, and it can cause things to bridge and make it difficult for that dust to discharge out the bottom. So just general condition of your airlocks. Same goes for screw conveyors, although they're a little easier, a little more forgiving on that regard, because the stuff just falls into the screw and gets pushed out. But specifically with rotary airlocks, you've got to make sure they're tight and they're operating properly. They have to be designed to the right capacity. So if you're overloading them, that's a problem. Yeah. And then generally there's a few things, little tools that you can use to help get things through the hopper, like vibrators and Worst case, you could weld some strike plates on there. So if you're gonna be banging on it with a rubber mallet, at least you have a welded thick gauge piece that you're not
Yeah.
going to be denting in the hopper. But that's the most common thing we see.
Yeah. Hey,
Yeah,
Scott,
it's
what about,
yeah.
I was just gonna say, what about at the last couple of places we went, we had problems with the hopper. What was that? Mind sharing that?
Yeah, sometimes people think that the hopper is supposed to be full or that there's supposed to be material always within the hopper. Um, the hopper is obviously designed to be able to collect the dust. It does fulfill that purpose, but only on a very temporary timeline, only until it can be released through the airlock, right? Some places we go to, yeah, you open up the dirty side, and then where the hopper is, it just spills dust. That's a huge hazard if it's anything that could start on fire, obviously. And if the dust is accumulating so much within that hopper, it's obviously not allowing the air to go through that airlock to be discharged correctly. So that could be one of the issues right there, right off the bat, as to why the dust collector isn't working correctly. Some places also, they have so much buildup in the hopper that it's actually pushing the filters and the cages up out of the tube sheet. That obviously is going to be a huge issue. That's going to affect the performance of the baghouse. So like Matt was saying, we want to definitely keep an eye on things. We want to do things, respectably as well. We don't want to just bang on the hopper and completely, smash it to pieces. But we definitely want to keep an eye on things as well, so we avoid buildup and things like that.
Yeah, excellent. Thanks, Scott. Well, I think I got, maybe for time's sake, maybe we do one, maybe just two more questions here that we can wrap up. Matt, what would you say? We had some questions that dealt with moisture in the baghouse. How can we control or minimize the negative effects of moisture in our systems?
So if moisture is kind of an innate part of your process and you're stuck dealing with it, then you want to certainly make sure that your filter is the right filter for that application. There are some filter medias and treatments that will help mitigate the effects of that moisture, like PTFE or Teflon coatings, which are basically like your non-stick pan. They're really hard to stick to. So they'll keep even moist dust from coating up your filters, and they're a little easier to clean and stuff. So that's certainly important. If it's a risk, if you want clean, dry air in there, and if you have high temp dust, you want to make sure that you keep it high temp through the entire system and including through the baghouse. If you have cold spots in your ductwork or in your hopper or your baghouse, you run the risk of that hot dust, dipping below the temperature, where the dew point temperature, where it basically turns into, condensation and moisture. So if you have to deal with hot dust, you need to use insulation and, if necessary, supplemental heating around your baghouse and your ductwork to make sure you avoid those cold spots. And so that once the dust is out of the baghouse, you can let it cool. But while it's in there and while it's in the ductwork, keep it hot.
Yeah, and a lot of that comes into with startup and shutdown procedures, right? When we have temperature changes and moisture, the startup and shutdown are just so crucial to make sure, like you said, we keep it hot so that there's no condensation in the system. All right, just our last question here. We had a question about undersizing a system. What does it look like when we have an undersized system? Somebody gave us a description that pretty well describes it. He was asking, what does this mean? And the answer is an undersized system. So maybe I can just explain this one. When you have a system that's undersized, like we said, it's a spectrum. It goes from working really well to not working so well to not working at all. When the system's undersized, a few things happen that you'll notice. It'll still be working, but you'll have a lot of times problems with a lot of holes from abrasion, right? You have a lot of abrasion at the bottoms of the bags, especially, and that's because the air speed inside, because you're pushing so much air through a small box, the air speed is so fast that a lot of times it causes more abrasion on the bottoms than we normally would see. But we can verify our system is too small by checking the differential pressure and how it relates to cleaning. So in a normal system, when we size it, we size the baghouse so that while you're running at full capacity, however much dust is coming into the collector can be removed by the cleaning system without having to shut down, right? So let's say you've got 1,000 pounds per hour comes in, We size the system so that it can effectively remove 1,000 pounds per hour or a little more without having to shut the system down, without having to turn the fan off. If it's undersized, what happens is 1,000 pounds per hour comes in, only 800 or 900 goes out at a time. And then slowly it kind of gets like overloaded, backed up slowly, slowly. So what you'll see is when you start up, the differential pressure looks normal. It goes up and then you clean and it goes down and then it starts building up again. But as you run for longer and longer, you start getting more and more overloaded. And then eventually you get the DP goes up and then you try to clean more and more and it doesn't quite go all the way down before it goes back up again. And then eventually it does that until it's just high all the time and you're pulsing continuously, nothing's happening until you turn the fan off. And then all of a sudden you pulse and it's like, boom, everything comes falling down. This is a sign that it's undersized because those velocities inside are too high for the dust to fall off while the fan's running. So this is why we caution people when they're told that they're supposed to clean down at the end of the day. In most cases, with pulse jet baghouses, in most cases, that's like a shorthand of we undersized it. You need to do this to give it breathing room again. It's like giving it CPR. Because if you turn the fan off, clean everything off, and then turn it back on, it's like everything's brand new again. The problem is then when you're running, right, it builds up and it can't keep up with itself long term. So you can get a system that's undersized, it'll work, but now you're running it in a way you have to shut down periodically, clean it offline, turn it back on. That's incredibly inconvenient, lowers productivity, production rates, right? And that's not how it's supposed to work. So you might save a little bit of money buying something too small, but you end up with those kinds of problems. So hopefully that answers that question that one of our attendees had about what that means when the DP goes high, stays high until you offline clean. That's usually what that's caused by. The system is undersized, or the cleaning system is damaged or something like that. It could be, but usually it's because the system is a little too small for what you're doing with it. All right. Well, I think we had a few more comments, but we'll have to save a little bit to leave people wanting more for our next one. So, but thanks guys for your answers there. Appreciate that. And I'll turn it back over to Matt here to conclude for us.
Yeah, well, thank you guys. And for everyone who joined, really appreciate it. I hope you got a lot out of it. And please, I hope you will go check out our new online training. I think it's really good. You know, everybody put a lot into it. So there's some really valuable stuff in there. There'll be a follow-up email here shortly from Andy with all the instructions and details. Any questions you may have about your system, the contact details for our team will be in that email. So you can reach out to us. We're happy to help, of course, with your system. That's what we're here for. And just thanks again. And for everyone who hung on the line here, we went a little long, but I think it's a lot of good questions. And, you know, that's what we like talking about. So we'll talk all day if you give us time.
That's right.
All right. I think that's it. Thanks, guys.
All right.
Yeah, thanks so much, everybody.
Thanks, everybody.
Thanks.
Take care.
Bye-bye.
Bye.